So we're going to look at equations now. So we're continuing that algebraic thinking idea. The addition property of equality is kind of a foundation that we utilize when we're solving equations. And what it says is if I add something to both sides, it stays balanced. The multiplication property is the same idea, but multiplication. And so I can generalize this even further and call it the addition and subtraction property, because if I can add something to both sides, that would include adding a negative number, which would be the subtraction form of it. Cancellation properties happen when I've got real numbers A, B, and C, and if I'm adding C to both sides and they're equal, then A has to equal B. And the same thing is true when I take the AC equals BC, well then A and B have to be the same by definition. So a lot of times we learn about this and we start talking about a scale and we have to keep the equation balanced. That's a good visual image for your students on helping them understand what's happening to one side has to happen to the other. So this is a good example of looking at that scale. So if I have 2 times 3, that's going to be 6, and then I have 2 times 2 is 4, plus 3 is 7. So if I look at that pan, the minute I let go of this, it's going to go down on the right-hand side because it's not an equal statement. Then, if I look at this example and I get 6 and 6, it's going to stay balanced. So the key that we're really trying to communicate to our students is, as long as we're doing the same thing on one side as we are to the other, it's going to maintain that balance. And that's also going to be true when we start comparing equations. So in the previous two slides, we had concrete numbers. Well, now it's possible for 3 times the square to be equal to 2 times the triangle. I'm going to have to set those two equal to solve for them though. So if my square is 2 and my triangle is 3, then I'm going to get the same value of 6 on both sides of the balance. And if I use 4, 3 times 4 is 12, and then 6 for the triangle, 2 times 6 is 12. So again, I'm staying balanced. Now, what's a great way to start teaching algebraic thinking to your students is by showing it on this balanced scale. So if it's at rest, so right here they're evenly lined up, then they're equal. So I'm going to set it up as 3x minus 14 equals 1. I want to isolate the x, so I'm going to add 14 to both sides. That would be considered the addition property of equality because you're adding something to both sides. Once I do that, I get 3x and 15. Now again, it's balanced, so if I use the cancellation property and I divide both sides by 3, I'm going to get that x equals 5 as a final answer. So these are just some review questions on solving equations. I'm not going to go in depth on these because you should have a fairly strong background on this, and if not, I have a YouTube channel and I do have information on solving equations. You can type that into the sidebar and pull it up. This equation is a little bit trickier, so we're going to go through this one step by step. The first thing we have to realize is that when a number is in front of the parentheses, that's going to be the distributive property. So I'm going to have to do 4 times x and 4 times 3. So I'm going to get 4x plus 12. Then I'm going to do 5 times x, 5 times 3, and that's going to be 5x plus 15. So I'm going to combine my 4x and my 5x, and that's going to give me 9. And then I'm going to combine my 12 and my 15. And then once I have all of that done, I've simplified the left-hand side as much as possible, and I'm going to solve for x. Here's a problem-solving example with a word problem. Bruno has 5 books overdue at the library. The fine that he has to pay is 10 cents a day per book. So anytime we're doing some multiple of something there, like 10 cents a day, that means that we're looking at a multiplication statement of 10 times the number of days. He remembers that he checked out an astronomy book a week before he checked out 4 novels. And if his total fine was $8.70, how long was each book overdue? Well, he had 5 books, and we knew that he checked them out at separate times. So we're going to understand the problem and go through and mark those things. I have different books. I checked them out at different times. The fine is the same no matter what. So then we're going to create a plan. So I know that the number of days that he brought it in One group came in 7 days later. Then the fine for each of the novels, like we said, is going to be 10 cents a day. You don't need to put a .10 in here. We can add that decimal in later. And so the fine for the 4 novels, if I looked at just one day, that would be the 4 times the 10, because I have 4 novels out. That would be 40 cents a day for all 4 novels. And then the astronomy book was checked out separately, and that fine was per day, but I'm going to have to add the number of overdue days of 7 to that one. So then my total fine is going to be the 40 cents for those 4 books, or 40 cents a book for the 4. And then 10 cents plus the 7 days. I'm going to distribute the 10 through, and then I'm going to combine my like terms, subtract 70 from both sides, and then I'm going to divide by 50, and that's going to give me 16 days. Now, the thing you want to avoid with your students is a lot of them can do this within trial and error. So you don't want to have them doing like a guess and check situation where they're constantly checking guess and check. That's not what we want our students to do. We want to help them set up those equations and solve them so that they're not stuck on something. And then we want to teach them to look back, see if it makes sense. If it makes sense, then you've got a way of checking your work and making sure that your answer falls in line with the context of the situation. Let's look at the same idea with the newspaper delivery. So we're going to go through the problem first, and we're just going to try and understand it. So we read it the first time for understanding. After we read for understanding, then we're going to start devising a plan and putting it into algebraic notation. So I know that Abby delivers 3 times as many, so that'd be 3 times what Bob has going on. Connie delivers 13 more than Abby, so I have A for Abby, add 13 to Abby, and you get Connie. And that when I add all these deliveries together, it's going to be 496. So if I want to reduce the number of variables, I can actually substitute Abby's amount with that 3b. And then when I add them together, it would become 3b plus b plus c equals 496. If I want to convert it over to one variable, well, then I know Connie was 13 more than Abby. Abby is 3b, so I'm going to add 13 to 3b, and that's what generates the question at the bottom. Then I'm going to carry out my plan, combine like terms, subtract 13, divide by 7. There's my answer. Is my answer going to be reasonable? Let's check it out. When I plug that in, I get 207. And then I can go backwards and solve for C and look at what Abby delivered and Bob delivered and Connie. So once I get that answer for B of 69, I'm working backwards to figure out the other people's paper routes. So then I'm going to look back at it and I'm going to think about this. Is Abby delivers 3 times as many? Does that check out with 207 equals 3 times 69? I'm going to check Connie. And then I'm just going to ask in general, if they delivered in total 496, does it make sense that somebody delivered 69? And it does. It's not completely out of the realm of things. So it's not like if I had a number greater than 496, a red flag would be thrown there. So you want to make sure they're reasoning through their answers to help with that.